talked about that the tangent slope is the first derivative. If I use this coordinate here, let's say, and I found its tangent slope, that's where it would cross in one spot, it would have a positive tangent slope, correct? And the graph is increasing there. What if I found the tangent slope on this point? It has a positive tangent slope and it's increasing, correct? Same thing here. If I found the tangent slope, it's decreasing and so is the graph. It's negative, and then the tangent slope on this side would be positive and it's increasing. So we're going to go through how the heck do we find the first derivative of things that aren't just power rule, but first off we'll start with power rule today. So the derivative of a constant, so d over dx of c equals 0. What does that mean? It means if I take the derivative, d over dx is a fancy way of them saying, I want the derivative without writing the word derivative. So d over dx of the number 6. The derivative of the number 6 is just 0. And the reason why is you use power rule. So, I'll show you why. So, this would be the same as 6x to the what? X to the 0. And I talked about power rule very quickly last class. I said what we do is we take the exponent, we drop it in front, and then reduce it by 1. Correct? So if I take the 0 and I drop it in front, I would get 6 times 0, x to the what? Negative 1. Now, what's 6 times 0 times x to the negative 1? 0, because I'm multiplying a 0 in there, correct? So that's why when you take the derivative of anything without an x, it would be x to the 0 and it would just go away. So the derivative of any constant number is 0. Now, the other one is the power rule. We talked about this. It says the derivative, d over dx, and it's d over dx because I'm using the variable x. If it was the variable was u, then I would do d over du. Of x to the n, remember we dropped the n in front, and then we reduce the exponent by 1. That's all the power rule is. And you can do it whenever you have a variable base to numeric exponent. So even if I had like x to the half, I could do power rule. Because you need to have a variable base to a numerical exponent. All right, so here, if f of x equals x to the 6, this is another way of writing the derivative. So if I want to say derivative of, I would just go d over dx here. This is asking for the derivative of f of x. This is the first derivative. Now the second derivative, they would write like this. The third derivative, they write like this. And then they stop doing lines. They go like this. I don't know why they stopped doing numeric, but they do. Math. Yes. So you need to know Roman numerals up to 3. And then after that, 4, 5, 6. I don't know. Someone got really not happy with the Roman numerals. So we want f prime of x, and it's of x to the 6. So I take the 6, I drop it in front. So I get 6x to the what? What's my derivative going to be? 6x to the 5. Done. This lesson should be easy. Next one. We have y to the equals x to the 1,000. So y prime would be 1,000 drops in front. X to the what? 999. Okay. This one says dy over dt, so this is Leibniz notation. So instead of writing y prime, they can write dy over dt because t is the variable, so it'd be dy with respect to t. This is the same as y prime. Dy over dt means the derivative of y with the respect to t because t is the variable they used. If this was an x, it would be dy over dx. Okay? So, what's the derivative of t to the 4? 4t to the 3. Done. Now, I gave you all the different forms so that you can understand them. Do you see how this one's dy over dt equals? That's the same as saying y prime. Dy over dt. Do you see how this one doesn't have a y on top of it? There's no equal sign in here. Do you see there's no equal sign? It's just the derivative of r cubed. So this is y, this is an equation. This is an equation y equals t to the 4. I want the derivative of y with respect to t equals, and then I find it. This one is, I just want the derivative of r cubed. It's not actually an equation. This is just r cubed, not an equation. So they can write it differently. Okay? So I want the derivative of r cubed, and it equals 3r squared. Power rule should not be where we're getting stumped. Okay? This one should be an easy rule. All right. So how can they make it a little different? So we bring back grade 10 and grade 10. I don't know why I said and. Grade 11, grade 12, I guess. So we need it to be a variable base to numeric exponent. Currently I have 1 over x squared. How could I rewrite that so that it's x to the something? X to the negative 2. So you can take this down here and bring it up here. It just makes your exponent the opposite, correct? So if it's x, the opposite sign. So if it's x put to the positive 2, if you move it up, it's x to the negative 2. If it was x to the negative 2 on the bottom and you moved it up, it becomes x to the positive 2. It just changes the sign. Now, if you don't believe me, type this into your calculator. Ready? Well, don't type this in. I hope you know the answer to this. What's 1/4? 0.25. How could I write this as an exponent? This is 4 to the what? Yeah, it's 4 to the 1 currently, which will be same as 4 to the negative 1, bringing it up. So type 4 to the negative 1 in your calculator. Dun, dun, dun. What do you get? 0.25, because it's the exact same thing. It actually works with numbers. They are the same. All right. So we're going to differentiate this. X to the negative 2. How do I differentiate? How do I show I'm differentiating when they give me an f of x? I go f prime of x, which means I'm finding the first derivative. I have a variable base to a numerical exponent. So I take that exponent, I drop it in front, I get negative 2. X to the what? X to the negative 3. We are subtracting 1. So the negatives get more negative, correct? The negatives get more negative. And more often than not, this will be rewritten in your textbook as negative 2 over x to the 3. Now, in grade 10, no matter how much, when I used to teach grade 10, no matter how much I told people, they always took the negative 2 with them. These are multiplied, correct? So much so that what's the exponent on the 2? The negative 2. What's its exponent? It's a positive 1, is it not? So does it need to move to the denominator? No. And if you actually moved it to the denominator, you would have to write this as 1 over negative 2 to the negative 1 x to the 3, which is ridiculous. Okay? So this is not attached. The only way the whole thing would move is if you had it like this. And is it written like that? No. So the negative 2 stays. It's the x that moves. And then you box it because you're proud of your answer. Okay, we had to do a lot of this in grade 12 already, but the reason why we were taught this in grade 10 was for this very moment. You were taught how to rationalize a radical. So if we have the cube root of x squared, your teacher taught you how to write this as a rational exponent. Remember, we took the index and we just dropped it underneath and we were done. So this is the same as x to the 2/3. That's it. We practiced it for like 3 days straight in grade 10 and still be mind blown that it was hard. All you do is you take that index and drop it underneath. That's it. It's crazy how grade 10 stuff seems so hard in grade 10, and then now it's like, what? That took me 2 days to learn that, and I still didn't know about the global meaning. Like, just drop it underneath. Boom, done. So, x to the 2/3. Okay, give me the derivative of that. Give me y prime. Go. So, we're going to drop the 2/3 in front. And we're going to get 2/3 x. What's 2/3 minus 1? Negative 1/3. If you don't know, you can go 2/3 minus 1. Well, 1 would turn itself into 3/3 so that you can actually make a common denominator. And so you get a negative 1/3. So we get 2/3 x to the negative 1/3. Does the 2/3 change at all? Does it flip-flop because we have no, the exponent on the 2 is a 1, and the exponent on a 3 is a 1. Those things aren't changing. No matter how hard I try to explain at grade 10, people will flip them. Those numbers have exponents of 1. They don't have the negative 2/3, right? But, or negative 1/3, sorry. But this is in the numerator, correct? So if I want it to be positive, I'm going to drop it down here. So I can rewrite them separately if I so choose. I could do this, which is going to be silly, times 1 over x to the 1/3. But the way they'll write it in the textbook is they'll make this join the 3. So they're going to write it as 2 over 3 x to the 3rd. Or they might write it with a radical. So in grade 10, we were taught to go from a radical to a rational exponent, and then we were taught to go from a rational exponent to a radical. So what is x to the 1/3 as a radical? Root 3x, because this just goes back into the index, correct? So this would be the same as the cube root of x1, x to the 1. So this could be rewritten as 2 over 3 cube root of x. The number on the bottom just goes either into the index or comes out from the index. That's it. Your top number stays your exponent every time. And after a week in grade 10, still flip-flop. It's crazy. Only if you go back. All right. All right. So I need you to graph this. Here. Go. All right. So I just sketched it off with my calculator. Nothing crazy. We could do t-tables if we wanted to. We could plug in 0, 1, and 4. They came out as nice numbers. But I just sketched the graph of y equals x root x. And so because there's going to be a lot on here, I want to actually label that as y equals x root x. The other thing, if you're doing proper graphs, is you're going to put x scale of 1 and y scale of 1. So that the person who's marking this knows that every tick on your graph is 1, 1. So here I want you to find the equations of the tangent line and normal line. I haven't talked about a normal line at all to you, so that's brand new. I did talk about the tangent. The tangent is just the first derivative. Every time you see that, it hints to us that we need the first derivative. The first derivative gets us the tangent slope. Not the line, just the slope. Remember? So in this case, if I want m tangent, that is equal to y prime, or the first derivative of y, right? We discussed this last class. So some people may say x root x. Lepp, how the heck am I supposed to do power rule, which is the only rule you've taught me? Yes. Yeah, the root x is x to the half. Yeah. So we are going to go y equals x root x, which is the same as x to the 1 times x to the what? What is the square root of x? 1/2. Now when you have the same base, same variable base, and we're multiplying them, what do we do with the exponents? Add. So we are going to end up with x to the 3/2. And that is something that we can do the power rule to, correct? So let's do that over here. So we have y equals x to the 3/2. And I want m tangent. I want the slope of the tangent. So I have to do the first derivative of this. So what do? I take the exponent, I drop it in front because it's a variable base to numerical exponent. So if I have a variable base, which is a letter base, to numerical exponent, I can drop the exponent in front. 3/2 x, and then subtract 1. When I subtract 1 from 3/2, what do I get? 1/2. Now, That is the general slope tangent. We agree? So I can take any of the coordinates off of here. I could take 4, 8, I could take 1, 1, I could take 0, 0, I could take the random decimally ones, and I can plug them in, and I'll get the tangent slope at that coordinate. And there's infinite coordinates on this graph, yes? But they specifically told us to find the equation, and by they I mean me, find the equations of the tangent line and normal line. So first off, we have to get the tangent slope at 1, 1. So we're going to use the point 1, 1, and that's the tangent slope we're getting. So we only care about the x currently because I have to put an x in here. So I am going to get m tangent equals 3/2, 1 to the half. I like when the exponent is a half because a half is just a fancy way of writing the square root, correct? Cube root is a third, fourth root is a fourth, square root's a half because the 1 just stays there, right? So when I see to the half, I like kind of throw a party because that's an easy one that we can do in our heads. So what is the square root of 1? 1. And what's 1 times 3/2? So our tangent slope is 3/2. We agree? Okay. Now, everyone put your pencils down once you have that written because I need all your brain power. No pencil power, no sidetracking. I will just give you time to write down anything I write. But I need all your brain power. So once you're done, put your pencils down. All right. The formula given to you in grade, I need an extra page. The formula given to you in grade 10, you're not writing any of this. I'll give you time to write this. If you're writing, you're not paying full attention, okay? And then you'd be like, what? How'd you get that? So the slope formula in grade 10 is taught to you as y2 minus y1 over x2 minus x1. And I've told you before, and I don't know why I write 2's in different, that's the thing. I just need to stop. I need to pick one and stick with it. I just kind of don't, and it's the thing. All right, so I like the top one better, but randomly I draw this, it looks like a Z, but who cares? So, in grade 10, circa 1999, you weren't even thought of, just so you know. I was in grade 10 in 1999. It was great. It was the best of times. It was the worst of times because don't give me that look like I'm not. I know, but that was the look. I saw it. I saw it. Cool. In grade 10, I had to do a slope quiz, and I got a 0. And I'm teaching you now, so you're welcome. But I got a 0 because I labeled the coordinates x1, x2, y1, y2. I still remember it in my head. I don't know what I was. Coordinates are x, y's. Yes? I labeled one x1, x2, and I labeled the other one y1, y2. No matter how you filled that into that formula, you were getting it wrong. So I got a 0. Like, that's impressive. To actually show a lot of work and still, you suck so bad you get a 0. So that was my quiz. I still remember it. It's just a side note. That's of no help to you right now. But slope is rise over run. And I've told you this before. It's just like getting out of bed. You have to rise before you run. And rising is the y-axis, running is the x-axis. So getting these opposite is not even a thought. You can't, correct? Your teacher in grade 10 taught you guys slope by intercept form. You're not writing any of this. Remember, you're just paying attention. This is all stuff you've been taught before where you didn't get zeros because you're not as dumb as me. You're welcome. All right. So, see, you can be dumb and still teach. You're welcome. If ever anyone's like, I can't teach. Yes, you can. I got a 0. It was great. All right, it was not. I think I might have cried. It's fine. I'm working through my emotions still. It's 1999. We're in 2020. Oh, my gosh. It's been a tick. Okay. When you say 2024, it sounds so, like, I remember thinking about that in 2000 when we thought the world was ending. Remember, you weren't born yet or thought of? And we were like, the world's going to end because the computers are not going to turn over and the power's going to... And nothing happened. We all bought generators for no reason. Nothing. The world kept going. It was great. Hence, you're here. All right. You were taught slope y-intercept form. There's also point slope form, which some of you were taught. Point slope form is crazy. It is labeled so well, it's not like Leibniz or whatever the heck his name is who labeled it himself. Point slope form you use when you have a point and slope. It's crazy, I know. So slope y-intercept form you use when you had a slope and a y-intercept. It's like the best forms ever. Point slope form is the slope formula rearranged. That's all it is. So if this x2 minus x1, I can move the whole thing to the other side by doing what to it? Multiply. So you're not writing anything. You're just taking in knowledge. So we are multiplying, and the color, whatever. x2 minus x1. Cool. Do as you wish, board. x2 minus x1. Perfect. Great. So we have technically y2 minus y1 equals m times x2 minus x1 if I rearrange the formula. Does everyone agree with that statement? Okay. In order to have an equation, you need to have a y and an x, yes? Even when we remember in quadratics or even in 30-1, when you guys were solving for your vertical stretch factor, you would solve for that a that was in front. You would plug in an x, you plug in a y, and you'd solve for the a. But then when you rewrote the equation, you left the y be y and the x be x and plugged the a in, and you had your x-intercept. Same thing. So point slope form needs a slope and a point. So the y2 and the x2 would be a second coordinate. We agree? And you would only need one coordinate and a second coordinate to solve for m. Because remember, whenever you're solving for a variable, you have to have, we're only missing one. We're not solving for m now, though. We have a coordinate and we have slope. So really, the point slope formula is just y minus y1 being the first coordinate equals m times x minus x1. X and y staying x and y so that it's actually a formula. It's an equation. M being the slope and x1, y1 being the first coordinate. That's why it's called point slope form, because you use a point and slope. You see how I got to this equation? Because some people struggle memorizing it. I'm like, it's literally just the slope formula with this moved up. That's all it is. So you can pick up your pen. Everyone back here. We're going to come up with the tangent equation of the tangent. We're writing the formula here. You don't actually have to come up with it. Equation of tangent. So I'm going to write the point slope form equation, which is the only thing you need from that, which is y minus y1 equals m times x minus x1. Oh, I forgot I'm using this computer and it doesn't let me extend page. The update on the Smart Notebook took away the extend page option. Ruining teachers' lives. Like, whoever did that was like, I'm going to make teachers' lives horrible. I'm going to take away the extend page option, and then I'm going to watch them. Be so angry. Because that's how I feel when I use this computer. So, we have a coordinate. We're going to label it x1, y1, not x1, x2 like an idiot, like little Crystal in high school. x1, y1. Do we have a slope? Yes. Please tell me you realize we do. It's what we found. So it's here. See it? Let's plug in our values. So we get y minus y1, which is 1, equals 3 over 2, x minus 1. And if they just want an equation, you're done. If you want to sketch it, can you sketch that currently? Is that a sketchable equation, how it is right now? What do we need to get it into? Yeah, we have to at least add the 1 over. I'm going to distribute the 3 halves in and then add the 1 over and get into slope by intercept form. But if I just ask for the equation, you're done. So you only have to move it if you actually want to graph it. So over here, I'm going to change it to y equals 3 over 2x minus 3 over 2 plus 1, which is y equals 3 over 2x minus a half. So this is the equation of the tangent in slope y-intercept form. So it's this is point slope form, or slope y-intercept form, which is y equals 3 halves x minus a half. So, both of those forms are good depending on which form you're asked for. I'm just going to leave it like this. So if I go to sketch that, can I sketch that line? It should be crossing through 1, 1, shouldn't it? So how do I sketch a line? 3/2 is like directions, right? The 3/2 slope, that's just directions. Up 3, right 2, correct? Up 3, right 2 from where? Yeah. -1/2. This is, slope by intercept form is like mapping. I tell you where you start, and then I tell you how to use directions, correct? So I start at -1/2. I want this to turn blue. -1/2. And then I'm going to rise up 3, go right 2. So I go up 3 from there. 1, 2, 3, right 2. And it should be so there's my tangent line. Touches in one spot. So you start at -1/2, you go up 3, right 2, up 3, right 2, up 3, right 2, and it'll go through the line 1, 1. If it doesn't go through 1, 1, you do not have a right equation, because it needs to be going through 1, 1. You found the tangent equation at 1, 1. Equation of the normal line brings grade 10 back again. Grade 10 never leaves, just so you know. I would like, and I told all my grade 12s last semester, and I'm telling you guys this semester, if you see a grade 10 in the hallway, tell them grade 10 math is important. We use it every single day in 30-1, and now we use it a lot in 30-2. Anytime you convert anything from a radical exponent to a rational to a radical, grade 10. Anytime you factor, grade 10. Anytime you reduce a radical, grade 10. Anytime you make an entire radical, grade 10. 30-1, almost everything is ended with grade 10 period. 30-1. Calculus and 30-1 is grade 10. 30-2 is grade 10 as well. There is no dash 1. 31. Yeah. There's just 31. All right. So, you were taught about the equation of the normal line without even knowing it in grade 10. In grade 10, you guys talked about slopes. You talked about parallel slopes, and you talked about perpendicular slopes. Once again, putting your pencils down, I'm going to remind you of grade 10, because if you forget about grade 10, or you're like, this was never taught to me, because you forget grade 10, totally fine. It was, but that's okay. So, pencils down, you're not drawing this. This is me just giving you a little rundown of grade 10 again. So, say we had y equals 2x plus 1, and I went to draw that. Okay? So I have my 1 is my y-intercept, and then I go up 2, right 1, up 2, right 1, down 2, left 1. So I go up 2, right 1, up 2, right 1, down 2, left 1, and we had ourselves a line in grade 10, correct? How could I get a parallel line to that line? Right, so we'd have to have the same what? Same slope, but different what? Y-intercept, correct? So you were taught about parallel. Parallel slopes have the same slope as that one. So if this one's 2, that one's 2, correct? What do perpendicular slopes have? Do you remember? How can I make a slope that's exactly the opposite way? First off, it's going to have to go like this, which means it's going to have to be, instead of being a positive slope, it's going to have to be what? Negative, and you're going to have to flip it. So it's called the negative reciprocal. So if this is 2, then the perpendicular slope would be -1/2. We agree? So if I started at 1, I would go down 1, right 2, or up 1, left 2, and I ended up with a completely perpendicular slope, a 90 degrees. See that? Make sense? So that's why when people didn't understand perpendicular, you should understand that at the very least it needs to be the opposite sign. Because in order for something to be perpendicular to another slope, it has to be the opposite sign, because if one's positive, the perpendicular would be negative. If one's negative, the perpendicular would be positive, right? So the sign flips. And then the way to get it to run 90 degrees to it, you actually have to reciprocate. Okay? So if we go back, talking about the normal. The normal is just the perpendicular tangent. That's it. So basically, if they ask you for the normal, you just have to find your normal tangent slope, like the tangent slope itself, and then you need the perpendicular of that. That's what the normal is. So you take your tangent slope and you take the reciprocal of it and the opposite sign. And you'll know you're right if I'm drawing a completely 90-degree line to that blue one I just drew. Correct? So tangent slope is still not, you still would have to find the tangent slope, which we did. It was 3/2. But instead of m tangent, we want m normal. So what is our slope going to be now? Instead of 3/2, it's right? -2/3. That was mind-blowing in grade 10. I couldn't get anyone to do a perpendicular line if I paid them for it. And then, heaven forbid, I give you the equation that has you pull the slope from and then flip it. Whew, we done. Go back to grade 10 in life. It's so much easier. So, we need the equation of the normal. So we're finding the equation. So we do y minus y1 equals m times x minus x1. Same coordinate, correct? The coordinate didn't change. So we're going to do y minus 1 equals -2/3 x minus 1. And if I just want an equation, you can be done, correct? If I want to graph it, though, to check it, I actually have to expand. Oh, I forgot this board doesn't move there. So I'd have to distribute it through. So I would get y. So this is an answer, and it's totally fine. If I want to graph it, though, I'm going to have to move that 1 over and distribute the -2/3 through. So I'm going to get -2/3 x plus 2/3 plus 1. So my other equation is y equals -2/3 x plus 5/3. Which is like 1.6 something. 1.6666. So it's like here. I'm going to use green. And then I'm going to go down to 1, 2, right 3. 1, 2, 3. Now, is drawing two dots enough, and now this is the most accurate graph you've ever seen? No. Keep doing your slope, and then actually connect all the dots, and then you have an accurate line, correct? Don't do what I did and do 2 dots and call it a day. Keep going 2 and 3, 2 and 3, 2 and 3, and then you go the opposite way, 2 and 3, 2 and 3, 2 and 3. Now, does that look like it makes a 90 degree with the tangent equation I made? Yes. I'm going to let you, we're going to come back to the notes, but after the notes there's actually homework. I'm going to let you do the homework question right now while this is still fresh in your head. So grab out a piece of paper where you're going to do your homework. You're going to submit it out. So I'll let you do the homework question first. I'll even write it down because I'm time.